Okay, hi everyone. This is day 5 of Advent of x86 for assembly. Yeah, okay, so let's do this. I'm a bit tired today, so I probably won't be able to get to part 2, but we'll see. Okay, day 5. If you give a seed of fertilizer, take the boat and find the gardener right where you were told you would be. Managing a giant garden that looks more to you like a farm. Water source. Island is the water source. Point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't mix snow with dirty water. Don't worry. I'm sure we get more sand soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that's headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac just arrived, and we're having trouble making sense of it. The Almanac, your puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number. The numbers are reused for each category. This is soil, and free and fertilizer are unnecessarily relate to each other. Okay. So, for example, seed to soil map, soil to fertilizer map, fertilizer to water map, water to light map, light to temperature map, temperature to humidity map, humidity to location map. Jesus Christ. Okay. So it's like a sequence of maps, and you just like go through the list, I guess, like dereferencing one after another, if you want one. If you want to go from one to another. Okay. Excuse me. Okay. Then Almanac starts by listing which seeds need to be planted. Seeds 79, 14, 55, and 13. Okay, yeah. The rest of the Almanac contains a list of maps which describe how to convert numbers from source category into numbers in destination category. The section starts with seed to soil map, describes how to convert a seed number to a soil number. Right. This lets the gardener and his team know which soil to use, with which seeds, which water to use, which fertilizers, and so on. Rather than list every source number and its corresponding destination number one by one, the map describes entire ranges of numbers that can be converted. Each line for the map contains 3 numbers: the destination range start, the source range start, and the range length. Okay. Consider again the example seed to soil map. The first line is destination range start of 50, source range start of 98, and the range length of 2. Source range starts at 98 and contains 2 values, 98 and 99, and the destination is the same, it starts at 50. Also, you can just use the offsets, I guess. Oh, that's cool. That's really nice. Okay, for this information, you know that seed number 98 corresponds to soil number 50, and that seed number 99 corresponds to soil number 51. Second line means the source range starts at 50. Oh, Jesus Christ, that's a lot of text. It contains 48 values. It corresponds to the destination range, starting at 52, and was containing 48 values. The seed number 53 corresponds to soil number 55. Any source numbers that aren't mapped correspond to the same destination number. So seed number 10 corresponds to soil number 10. Oh, that's interesting. Okay. So the entire list of seed numbers and the corresponding soil numbers looks like this. This map, you can look up the soil number required for each initial seed number. Wait, where soil and seed numbers? I'm lost. Oh, right, that's just seed to soil number. Yeah, okay. Yeah, the gardener and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. To do this, you need to convert each seed number through other categories until you find its corresponding location number. Do you? Do you need to do that, or can you do that like by reversing the maps? Can you? I guess it's easier if you just loop through the soil number. Actually, is it? Yeah, I think it's easier if you just do it the way you're supposed to. Okay, so that's that seems like it's just the same thing like 8 times or whatever. Okay, that yeah. Okay, we can work with that. I don't think that's that hard. Okay, so let me switch on screens. We can actually start writing some code. Okay, so day 5, we have 1 GDB in it. Yeah, I don't know, I guess we keep some probably. And we keep some of the code. Okay, so what do we need? So from our data section, we need our input buffer, input file, whatever, look at chart, total sum. We don't need any of those. And in our code, we keep an EOF. We need to have this, or this, or this, but we need start. And I think, yeah, that's actually it. Yeah, okay, good. Okay, so we are ready to actually get started. Okay, so what do we even need to do? Let's get our input. So we need to this is so annoying in assembly. This would have been so much easier in like any high level language. Like in a camel this would be really easy because you could just you could use like a map where you don't use regular comparisons, but you do like range comparisons. And then you can just use a regular map and map to the offsets, I guess. Yeah, that's so much easier. Okay. So I guess okay, one thing we need to do is if we have a range, if we have what's that? That's start index and length, or wait, it is destination range start, source range start, and range length. Okay, so that's our destination range start 0. That's our source length start, and that's our length. Okay, so we actually only need those, and we want this one to be our offsets. We actually want to do that one minus that one. Okay, so let me just write it down. So what we actually do is if we have let me write that in the code. So we actually have it here. Okay, so we have our destination range start, our source, and our length. So we have like x here, here and here. Then what we actually want in our like table thingy is we want the source range and the length, and then we want the offset, right? So that's just why z, those are alright. Actually, we don't want length, we want end. So that's y plus 3, and our offset is x minus y. Yeah, okay. So that's actually the table format that we want and that we're going to pass into. Because that's way easier than we just check between source and end and like compute the offset. I guess, yeah, we could do like a binary search tree or whatever, but those aren't, yeah, like those are tiny maps. That's probably, yeah, linear lookup is going to be faster even. Oh, like, that one is not as tiny. But yeah, yeah, like binary search trees sound really complicated with like these range lookups. At least in assembly, if like messing up is really easy. But yeah, I think it's easier if we just do an array and like just do linear lookups. Hello, yeah, day5. Day5 isn't that great for assembly, to be honest. Like it's just like map lookups. You have a map of ranges. Actually, that's the range. Like that one, that's the start, and that's the length. And then that maps into like a different range, and then you compose all those maps together. Actually, can we compose those together in one pass? Can we do that? Because like we don't actually care about the individual maps, right? We only care about the composition. Like, about C2, what's this one? C2 location, I think. Yeah. Can we compose two maps together? So we have like I don't think we can. No, I don't think we can, because those might, like the end ranges might overlap, and that's weird and complicated. Yeah, and I don't think that's worth it. But I don't know, like in a high-level language, I'd actually really like to try that. Yeah, no, let's not do that. Let's just do the obvious thing. Okay, so this is kind of awkward because we don't have dynamic memory allocation. So let's just count how many, what's the maximum number of, I guess that's never like more than 100, right? Yeah, it's less than 100. Let's do 1,000, why not? Let's do 1,000 per map. Okay, so we have our maps. And I guess there are so many that we're just gonna use like an array of maps. How many do we have? We have 1, 2, 3, 4, 5, 6, 7, 7. Okay. Okay. Yeah, actually, I don't think like composing those together even helps at all. Actually, do we even care about building up the map? Because I think we can just do this in one pass, right? We can just remember all the seeds, then look through each of those, and like map it correctly if our seed matches. Yeah, we can just destructively like map our seeds. Yeah, okay, so actually, yeah, that's way better. That's way easier to do. And then we don't actually care about the different kinds of maps you have. Yeah, okay, that's way better. Let's do that. Okay, so what we're gonna do is instead of like building up those maps and then I don't know going through them, we are actually gonna do this kind of not quite in reverse, but like in a slightly weird order. Because we're gonna save our seeds, right? So we have one array of seeds. We have like something, and then we go through each of those, and we like destructively. I guess do we do it destructively? Yeah, we do it destructively, but we also need to remember if we can. No, actually, we don't need to remember if we've modified them, because if we don't hit any, they just stay the same, right? I think that's kind of an intended solution even. Because otherwise they wouldn't stay the same if they're not hit. Okay, so we keep those, and now for each line here, we try to map every number through that range if possible, which is not going to be possible most of the time, but might sometimes. And if it is, then we like update our number. Oh no, and something else. Yeah, and then at the end, yeah, we just repeat. Yeah, that's so easy. Okay. Right. So yeah, so it's actually really easy. Okay, so what do we need to keep track of? Yeah, we don't need the total sum then. Yeah, we only computed that at the end. So let's actually move that here. So we need our seeds. Actually, those aren't seeds, I guess, or inputs, whatever those are. Like they're seeds initially, but we're gonna mutate them to soil or fertilizer or whatever. Yeah, okay, so we're gonna have our inputs, and those are 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Too many, like, let's do 100. Okay. 100, and let's do input count. Just because we can. Okay, so we have our inputs array, and I think that's all the static memory allocation we need to do up front, or all the memory allocation at all that we need to do. Yeah, and then we just go through each map. Yeah, so we pass our seeds, and then as long as there's an input, we skip to the colon, then read all of those. When we find a new line, yeah, keep doing that. Yeah, I guess actually it's really like those are equivalent if we do like this. Like we don't actually care that those are separate maps. Because if we destructively update our inputs, actually this might not work. That might not work. Okay, so yeah, okay, there's an edge case. Okay, if one of those maps, like say we have our seed is 1, and this one maps 1 into 2, this line, and then let's say this line maps 2 to 3, then we don't want to map this one twice. So we actually need to keep track of which ones we've already modified. But that's fine. Just use a like Boolean array. Like a bit set. Except it's not a bit set, it's like a byte set, I guess. I don't know. Because bits are kind of annoying to work with. Okay, so let's... Yeah, but that's easy, because then we just reset this one on every like new line. And yeah, that's it. Okay, cool. Yeah, so that should actually be really easy. Okay, so first of all, we're gonna pass our initial inputs. So I guess, how do we do that? We skip until the colon. Yeah. Skip to the initial colon, and we're gonna do that. Maybe just read one character. If our character is colon, we jump out. Exactly like we did last time, pretty much. And otherwise, yeah, we just jump back and keep reading. Actually, we can do a jump not equal to this one, and then we can save a jump there. Is that what I did last time? I don't think so. I don't know. I don't really care. Okay, so we read this one, and then we just read numbers until we hit a new line. Yeah. Okay. So we initial numbers, initial inputs. Yeah, right. So seeds are our initial inputs, but we might like mutate them into soil or whatever. Okay, so right, read our initial inputs. Those are actually I'm just thinking we could try to do like a trick to avoid the bit set, but that's not worth it. No, that's way too annoying. We could like so here's a fun idea. We could have like our inputs and our outputs, right? And have two arrays, and instead of mutating one, we have we like fill one up in reverse. Actually, we don't need to do it in reverse. Doesn't really matter. Yeah, so we have like our inputs, and then we this one's mapped to 4. We actually just put a 4 on the output. I know, but then we need to carry over the input that we haven't modified. Yeah, no, that's not worth it. Let's not do that. Except we could like copy our input, and then if there's a 1, we actually just modify it in the output. Oh, that's kind of elegant. And if that one is 9, then we don't have that in the input. You know what? Let's do that. Let's try that. Are we gonna try that? No, I think modified is still easier. We just skip the ones we've already modified. Yeah, never mind. Let's do it like that. Okay, so let's actually do something for change. Okay, so we read our initial seeds. To do that, what are we gonna do? We read the number. Actually, we need like let's use R13 because why not? As our index into our input array, right? We read a number, move, what's it called? Inputs, plus R13, RBX, that's our number, and our AX contains our last character, so we need to check if that's a new line, because if that's a new line, we are here. Then we jump out and actually continue doing actual things. So we do compare ix. And that's times 8, because it's an 8-byte number. Okay, right, so save the number. And if ix is a \n, which is not, that's not a new line, that's the / character and an n character. Need to remember that. If we have 10, that's like \n. Or in new line, not a \n. If we have that, then I guess we can just, if it's not there, we jump back. See that? Yeah. So if we haven't found, if we haven't hit a new line, we just keep reading. Actually, we need, never mind. If we have found one, we jump out, and otherwise we jump back to the start. Because we also need to increment R13 and stuff, right? Yeah. This looks properly. Okay, so we read one number, we store it in our array. We compare, we check if we had a new line, if we do jump out, and otherwise increment by 1 and keep going. Okay, cool. So now that we're done, we can store our count into what it's called, input count. Right. Okay, so that's the number of seeds we've read, and those are inputs. So then we keep reading until we hit a colon. And actually we do that in a loop, I think. Yeah, we do that in a loop. Keep reading until we get either an end of file or a colon. And once we do, I guess just keep doing reading numbers. Yeah, okay, cool. Yeah. Let's start our main loop here. And what do we do? Okay, so skip until first colon or the file, right? Because that's also an option. So we do it's also skip until colon, but let's put an initial there. Okay, so let's skip until okay, so we read character, we check if we have it's nice. Check if we have hit a 0, so it's not a file, and if we do, jump on F. And otherwise, if we hit a colon, we jump out of this loop. Okay. Okay, so that reads until here, up until and including that character, and then there's a new line, but yeah, we should skip the new line actually. Okay, right. So we skip the new line, and then what? Yeah, I guess then we just process each line in a map. Each entry, I guess. Maps, so that means, yeah, that's gonna be a little tricky, but actually no, that's gonna be easy. That's one input. Okay, so we just read 3 numbers. So I guess we read number, and move that one into, let's use R12, R13, or 14. Why not? Because I think those are quality saved or core. I always forget the order. I think, yeah, quality saved means it's safe for us to use, right? Yeah. Yeah, I think it does. Okay. Right, so R12 is, what is that one even? That's our destination. Actually, maybe we, yeah, might need to shuffle some of those around to get our, the font we actually want here. But that's, yeah, that's not difficult. So yeah, let me read another number. That was 13. So 13 is our source. And then 14 is our length. Okay, now we want to convert to the to an easier format. Excuse me. Okay. Yeah, so does that work? Guess it means we want I guess it doesn't really matter, does it? So we do let's use this actually, yeah, you know what? Let's use RBX and CX here. Just make this oh, actually we can't use RBX because we're gonna call read number. I don't know. Yeah, I guess we don't need to call any syscalls anymore. Yeah. Wait, so we want source, we want y to stay as it is. We want, actually no, that's easy. So we do length, so that's our 14. We're gonna add, yeah, we're gonna add the source position to that, yes. So that's 13. So that now our 14 is equal to our destination. No, not our destination, but our end location. Or end index, I guess. Hello. Yeah, we're doing day 5, if you noticed. Yeah, it's actually not that hard. It's kind of cool. We can so the thing about doing like these things in assembly is you kind of like the intended approach usually doesn't work that well. Like you could store each of those in a map and then like traverse every map for every input, but that's kind of horrible because like you need like technically you need a dynamic memory allocation. You can't just say like there are only about like 100 lines, so you use like an 100 element array. It's statically allocated and you have 8 arrays and you like manually jump through each one of those. But like there's a way easier way to do this. Which is just to like do it in not quite in reverse, but kind of in a weird order where you like you remember the seeds and then you map like for every map you like destructively update each seed to the soil. And if it wasn't hit, it's just it just stays itself. That's like how it works. And then yeah, you just do that for every input. You can just loop through. You don't need to like do 8 separate maps or whatever. And that should give the same result. Probably faster because those are kind of small maps. But yeah. Yeah, so it's actually probably faster and much easier if we do it in a slightly unconventional way. That's kind of cool, honestly. Yeah, okay, so the destination was R12. We subtract, y, that was our source, that's R13. Okay, so R14 is our end index, R13 is our offset. And our source is just y, so that's R12. Is that R12? Did I do that correctly? I did not. Whoops. Shit. Okay. Oh, actually no. R12 is our set, and R13 is our start position. Right. Okay, that works. So R13 is our start index, or the start of our range. R14 is the end of our range. And R12 is the offset that we apply to something in this range. Okay. Gotcha. Yeah, okay. So now that's our format. And now I guess we can just process each method. So with a loop. And what do we do? In this loop, we read 3 numbers. Actually, no, wait, that's our mapping already. Whoops. To process each input. Yeah, so actually we do this Ix is our input, so our index into our array. And now we do increment Ix at the end. And we do compare Ix with, what's our name, input count. And if it's greater than or equal, we jump out. Just a regular for loop notch. Okay, cool. That's our loop. We can loop through every single input, right? And then we process each input, right? So we check if we have like a skip mapping in here, or skip seed. So we can do it like from the perspective of our mapping, right? So we compare what's Ix, right? We compare input, not input buffer, what's it called? Inputs. It's ambiguous. Plus Ix times 8 with our start range, so that's 13. I don't know if our ranges are inclusive or exclusive. Actually. Yeah, so let's just try inclusive and change that if it doesn't work. Yeah, okay, so if it's less than the start of our range, let's get the seed. And if it is greater than the end of our range, then we also skip it. And otherwise, actually we first of all check if we have already processed the seed. It's something called modified, right? Yeah. It's actually not times 8, because it's a byte. It's modified as a byte array. Right, so if that one is 1, if we have already set it, then what? We also jump to skip seed. And otherwise we put the start of our range and the end of our range, and both of those match. The input is in our range, and so we apply our offset. Yeah. And then, yeah, and we also set it as modified. And that's it, actually. That's all we need to do for one what's it called, one mapping. We do that for every mapping, and then once we're done, we add process. Wait, what's wait, that's weird. Oh yeah, okay, we need another loop here. Yeah, so we need one more loop here. And once that one's done, let's actually indent this. Yeah, once we're done with one mapping, or one entry, I guess, let's call it entry. less ambiguous. Once we're here, we jump back to our loop, and once we jump out, yeah, so if we haven't skipped our seed, we jump nowhere, never mind. We jump out actually if, when do we jump out? If we hit a new line. That's annoying because we need, yeah, because that's an IX here. But we also need IX down there. So actually let's just use RBX down here. It's easier. We don't call anything, I think. No, we don't. Yes, we can just use RBX here. And so if we're done here, then RBX still character. It's a new line. We have completed this map. Right. So if RBX is a new line, then we jump out of the loop. Yeah, that's that. Actually, we can do that. If it's not equal, we jump back in, and then we don't need this label or this additional jump. Okay. Yeah, so that's that. And now we reset our modified buffer. So we move I guess move x0, and we just loop through all 100 entries. So we don't actually only need to loop through input count entries. Yeah, that's easier. Yeah, so it's a reset loop. Excuse me, really getting kind of sick, I guess. Yeah, okay, so yeah. Do we need to reset input count? I don't think we do. Oh no, we don't want to reset that because our input length is still constant. We just reset our modified buffer. Yeah, okay. So loop while ix is less than input count. So in other words, if it is greater or equal to input count, we jump out. So done. Otherwise, we print x and we move inputs plus x times 8. 0. Oh, actually not times 8. But it's a byte array. I guarantee you I've messed that up somewhere. Right, so inputs plus ix is 0, then we increment ix and keep going. And once we're done, we do what? We jump back to the loop. Is that it? I think that's it. Okay, and then on your F, we find what? What are we even looking for? The smallest, the lowest location that corresponds to any of the initial seeds. Also, I guess we just, yeah, find the smallest number. No, in our inputs. Okay. Yeah, so I guess it's just another loop yet again. Keep that one RBX, I guess. Yeah, you know, it's not empty, so we can just, yeah, keep the first element, and then next loop, that stuff here. That's our loop. We go through each element, so we start at x0, and if It's basically writing C with an assembly. Like, it's really not that complicated today. That's kind of nice. Oh, on the fifth, it wasn't that complicated. I'm slightly behind. Let's creator, we jump out. Done. And otherwise, what do we do? Yeah, we compare input count plus ix times 8, input and input count inputs, plus x times 8 with abx, and if it is greater, we can conditionally move back into it. We might need to move this into a register, I'm not sure. So yeah, if if that's larger than, oh actually, yeah, if that's larger than RBX, we conditionally move that into RBX. And we keep going, yeah. And that's our maximum, so RBX is now our maximum. Let's move that into our AX, and we print it, and that's it. Does anyone think that's gonna work on the first try? Me neither. But yeah, okay. Non-constant supply times what? Times 100 DQ. So keep messing that syntax up. It's not that complicated. Operation specified, that's a byte. And so is this. Start mapping loop. I didn't call it mapping loop, called it process entry loop. Is it the same one? Wait, that is wrong. No, that's process input loop. Which is not specified, that's a byte. And infinite loop. Okay. But that's fine, I guess. Let's put our inputs into GBinit. How many are there? Just not. Why count if you can use Haskell? 20. See? Way easier. So that's an array of 20 nonce. I'm stuck. Oh no! Oh, the stupid OBS bug again. Let me just switch my screens. Did that help? Yeah. Okay, cool. What's the assembly reference segmentation? I don't know. I actually don't know any great assembly reference segmentation. There is, like from my assembler, from NASM, there's... Well, I mean, the documentation is pretty good, but it's not about assembly, right? So, like, it has all the opcodes and all the, like, possible argument combinations for each instruction, but it doesn't, yeah, that's one. But it doesn't, have, like, any descriptions of the instructions. It's kind of, yeah, but it's alright. Usually you can just Google stuff, I guess, and that works. But yeah, I'm not using any like super complicated instructions. It's all like super basic x86. So, yeah. Okay, right. So we have set up our GB init. So let's I guess break on. What's the one where we after we have read our initial seed loop here? Read initial seed loop done. Let's break there, let's run. And that's, is that correct? I don't know, that's also weird. Yeah, that seems to match up. Yeah. Yeah, that looks good. Okay, yeah, so it's really hard to see what's going on because the numbers are like the numbers look wrong. That's kind of the issue here. But I think it's fine, right? That's gonna be fine. Actually shouldn't have stop there. Okay, so it's being read correctly. That's a start. So let's break on loop, I guess. Yeah. Go on next. Wait, that's skip alternative colon loop. Yeah, that's the one. Okay, so I guess yeah, so I guess we should break on process entry loop. Oops, that's did I break on that? Yeah, that works. Ah, shit. Let's skip the first one. Okay, but that's fine. So process entry loop, so we should be here. And so read number should return 4174. Yeah, that's that one. And it moves that one correctly, and it does whatever. Actually, I have no idea what that one should return. Yeah, you know what? Actually, let's just keep going. Let's track, and yeah, let's just keep going, and I guess look at those numbers. Yep. So at first is 32. That seems wrong. That seems wrong. I'm not sure what's going on here. But RBX is 177 something. Ah, that one. Yeah. R12 is IAX. It's that one. Oh, that's not IAX, that's RBX. Oh, I'm such an idiot. RBX is the return number. IAX is the last red character. Yeah, okay. So that should be better, but shouldn't change anything with internal loops. Yeah. Should have just read the wrong number. So I guess let's break on process entry loop done, because I'm not sure if that one completes. Wait, that doesn't happen. Done. That's what I get for writing my loops like that. So I guess that's called reset loop. And that one, yeah, that never finishes. So it somehow mispasses something here and never actually ends up here. What's that? I'm not sure. So that's process entry loop. Yeah, let's try let's try just skipping through all of those until we hit the last one. I guess we can maybe we can just check that Ix is correct at the end. So I guess it's this one move 10 into Ix. Wait, that seems wrong. Oh, I'm an idiot. Yeah, okay. Wait, shouldn't that's weird. Because now if you return, wait, shouldn't that have jumped out after the first line already? Strange. Oh, oh, right, that's that massive into documentation, but that's like 400 pages or something, right? Yeah, I think, yeah, I know that one. I think the full one is like a few hundred pages. Wait, projection, yeah, okay, gotcha. Huh. Oh yeah, oh no, it's not 400, it's 5,072 pages. Jesus Christ, okay. Yeah, so I guess if you want to read 5,000 pages of assembly documentation, that's the link for you. Okay. Right. I'm kind of confused because that's RBX. I'm such an idiot. I messed up RBX and AX, and even then those are wrong. So I think I need one character of look ahead actually. No, I don't. Actually, I can. Yeah, I do. Yeah, I do. So I've read until here, and I need to check the next one, and if that one is not a number, then we need to like this is done. Okay. So I guess we need to use our look at character buffer thing. Directing and initializing. Yes. Formula and CPUs. Yes, it's just running on my like 6700K. So yeah, it's just direct x86 assembly. Nothing like super fancy, so I'm not using like SIMD registers or anything. Mostly because I don't know how to. But yeah, it's yeah, standard Intel assembly. Okay, it's actually each one character ahead. Let's see if we hit the end of one. No. Okay, so we call the char again. Actually, didn't need to use RBX in here. Could have used RAX now apparently. Oh well. And now if result of this one is a new line. We can and now that one doesn't work again, so I need like a fancy looping. Less fancy looping, I guess. Into done. How's the change going? It's going pretty well actually. Yeah, so day 5 is actually pretty easy, at least part 1. It's just like looking through maps, and you can do it in one pass. Like you can keep the seeds and then like immediately apply each map, and then it's actually pretty straightforward, I think. I haven't run it, but it's I'm just fixing some infinite loops right now, so don't quote me on that, but I think it's pretty easy. Okay, right, so we have read a character. If it's 10, we can jump out. And yeah, that's wrong. I mean, that's not, well, if that was IX, that would be correct, but that's this character, right? This new line, not this new line. We need to read one ahead, and then we haven't jumped out. We need to install this lookup character. So let's move. Support lookup char. X. Right. It's pretty easy, thankfully. And then we jump back into the main loop. Well, not the main loop, but this loop. Right, okay, so process loop done, and I think that should work. Hopefully. It doesn't. Okay. Okay. was worth a try, I guess. Does it ever hit process until you're done? Yes, it does. Okay, so this works, presumably. I have no idea if that's correct. Like, literally zero idea. This could be completely wrong. This could be memory corruption, and I couldn't tell you. I mean, they're not negative, so they're probably not memory corruption, but that's about it. So what does modified look like? We should probably print that one as well. That is there's no byte in C, right? There's no way to do like, is there a way to print like the characters but not as bytes and not as like characters? I guess it works. So yeah, the first one, actually wait, most of those were hit. I guess that's, yeah, that, I don't know, seems legit maybe. Actually no idea. It could be correct, could be incorrect. I wouldn't know. But after a reset done, it should be 0. It's not. Great. Okay, so that did nothing. Oh, because I'm resetting inputs. Whoops. That should be modified. Not inputs. Mistakes. I'm tired. I can tell. That shouldn't have changed anything though. Yeah, termination's going wrong somewhere else, but yeah. This is still wrong. It's just not the main issue right now. Let's break there, and let's break on reset done. So yeah, modified is that, and then it's 0. Yeah, okay, perfect. So resetting works. Yeah, seriously. I mean, usually I'm that person who develops high-level languages, so you're welcome, I guess. But yeah, I know, I think assembly is really fun. It's just, yeah, you wouldn't want to write like any interesting data structures here. I'm actually kind of scared for some of the later challenges, because like right now you don't need any data structures, right? This is just like even representing this as like a binary search tree is like, inefficient, right? It's so small that like a linear array is just the fastest thing you can do. But that's going to change, and that's going to be really tricky in assembly. So we'll see. Yeah, okay. Also this is kind of ugly, but I'm not ready to change it yet. Because like you, instead of jumping to reset, then you could immediately jump to loop. But oh well. Okay. So where could this be going wrong? And let's check the second iteration, I guess. Actually, maybe this is the issue. No, that shouldn't be the issue. Wait, what happens here at the end? We had our last map. That one reads a new line, and then it should jump into the correct thing. Actually, let's just try that. Let's break on. What are we gonna break on? Loop, I guess. Okay, so no. So we're currently here. Now we should be. Doesn't look like anything has changed. We should technically be here. Wait, are those identical? Did anything change between GDB show me previous thing? I know. Actually, no. Here? Didn't this count? Wait, those look identical. Yeah, this didn't change at all. Oh, I think, no. Okay, I messed something up, but that shouldn't be the issue, right? There should be something, like that shouldn't cause non-termination, I guess. Wait, so, okay, so we're here. And now we are here, technically. Let's actually go through that a bit and see if that's correct. Next. That seems wrong. Uh-oh, that's way too long. Oh god, something's going wrong. Something's going very wrong. Oh yeah, that's wrong. That shouldn't be 1700. Should it? I don't know. Let's offset 1700 and the thing. Actually, we can try that, I think, if we do a read file. And then we just like drop 1700. That should be input from there on. It's a why are the dots? What happened there? What? Oh, I'm in the wrong directory. Where should I save? Yeah, I do. Nice. What? Yeah, okay, so that's where we currently are. That's wrong. Yeah, that's very wrong. That's I don't know what went wrong there. Okay, so let's rerun. Let's also reset our breakpoints. Okay, so in our main loop, if we shouldn't break there, we should break on in reach now. Skip until map cron loop done. That one. What a name. Yeah, so we should go there. And now what? Now we read a new line. That's not a new line. Fuck. Oh no, wait, I'm on the... No, I'm on the correct line. That's not a new line. Okay, so this is wrong. How's that wrong? That's not complicated. None of this is complicated. What? How does that work? What? Okay. We run until skip until F loop, right? So we read one character. That's a new line. Yeah, right. That's this new line, I think. Yeah, this new line. So the next one should be an S. Right? 115. That's actually, I think I can put it in here, right? Yeah, that's an S. Okay, so we're here. That seems correct so far. We should skip a few more, actually. Yeah, add an I, so that I, presumably. Let's skip 1, 2, 3, 4, 5 more, definitely. And now we are at the P here. Yeah, so the next one should be a colon. Yeah. Okay, so we're here. Now what? That's not an under 5. It is a colon, so we should jump out. Yeah, we do. What? Okay, yeah, so everything is going well, except when it's not. What? Wait, what happened? What happened there? Skip internet moment. What? Didn't we just jump out to this read char? What? Okay, that's I'm so confused. Okay, let's do that one again. And let's continue and actually display char Ix. We know when to stop. Map colon. Okay. We read this. What? Oh, I didn't set the breakpoint correctly, I think. Map. Okay, now it's a colon. That's not a 0, so we don't jump out. It is a colon, so we jump to this loop. Yeah. Now we're in read char. We read one new line, and that's not a new line. What is that? What? What? We read this new line. Technically. Not read 0, 23. What even is that? Is that like a non-breaking space or something? Or like a special kind of new line? Backslash R, backslash N or something? What? Excuse me. ETB, what even is that? End of transmission block. Okay, I have no idea what that means. Did I do that, or did Advent of Code do that? Because if Advent of Code did that, that would be such a strange thing to do. Okay, let me just recopy my input. Be sure. Actually, just realized I completely forgot to play any music. Oh no. Let me just change that. Okay, cool. Yeah, so... Okay, let's try that, I guess. You can just copy that out into GCI and see if it's correct. Actually can't. Wait, that doesn't. But that seems to be a new line. No, that's no idea. I know. Let's retry. Still runs an infinite loop. that's yeah, that's correct one, and now that's a what? Wait, what? Where am I? Loop done. It's here. Yeah. Why isn't that? What's wrong with my G? What's? Oh God, Jesus, GB. What's happening? Okay, let me just restart GDB. What? That's one instruction. That shouldn't. What? What's happening? There's one instruction here. This shouldn't like keep hitting the breakpoint or doing whatever that is. Oh my god, I broke GDB. I don't know how I broke GDB, but apparently I did. I guess let's not break that. Let's break on the one above. Let's just try again. So map. Bam, and now that's what's the next iteration where something's wrong? I guess it doesn't actually matter what shard that was. I'm still very confused by why that would be something weird like that. E2 soil map. That's gone, then this one should jump out. Wait, what? Once again. What I did? What? Yes. Okay. Okay, somehow we're going instruction by instruction. I somehow skipped this whole thing. I don't understand what's happening. Let's something is really weird here. Okay, let's break on this loop, because that's where everything should end up. Yeah, see, now that I'm breaking here, everything seems correct. It's now reached just 10, like it should be. Right, because we've read this new line. I don't know what was wrong there. It might be like a weird GDB bug or something. Maybe. I don't know. We read 3 numbers we can check. So a 12 is 0, that's correct, yeah. A 13 is 6996 something. Yeah, that should be. And a 14 is 9226 something. Yes, okay. And now a 14 is something. A 12 is negative, yeah, that's correct though. Yeah. And now VX is 0. Wait, move VX 0, that seems weird. Oh, actually that should be XOR. But that's like fewer bytes to encode, so it's faster. Okay, yeah, so that seems to be going well. Let's try the next iteration. And we have modified 2 numbers. Yeah, okay. That makes sense. 2 numbers in the range. Seems realistic. And so now our 12 is 414 something. Yeah. Okay, so seems to be correct so far. Let's skip a few. It's 1, 2, 3, 4. Actually, yeah, inputs didn't get mutated though. That's wrong. Where am I moving? Where? Shit. I lost my map. Yeah, okay, let's check that in a second. Where am I even setting inputs? Oh, I guess I'm adding R12 here. That seems like it should be working. Not sure. Yeah, let's check that in a second. And first of all, what's the number here? R12, that's 3, 6 something. It's here. Let's skip to the end. So that's 1, 2, 3, 4, 5, 6 more. And this would be for one, yeah, it's that one, so we go one more. Now that's our last, our last line here. Okay, great. So we are, we are here. Now last iteration in process entry loop. Right, so we want to skip process input loop to process input loop done. That should also just be able to continue, right? Yeah. Perfect. Okay. And now what? We check the next character. That should be a new line now. Yeah, and it is. So actually we just jump to process entry loop done. And we have set something in here. Yeah, that seems, I mean, that seems incorrect, I think, because that's unchanged from, no, that's not in, what? And that 0 seems weird, which, actually no, that seems fine, mostly, I guess. Yeah, so we are done with this iteration of the loop, so we just reset our thingy, and wait, reset loop? Yeah, reset loop. So we, oops. We go and we keep going until reset done. Yeah, no reset has been reset. And not reset, modified has been reset. Everything here seems fine, and we go into a new iteration in our loop. I don't see why this should run in an infinite loop. What we see. Okay, so we have finished this one, so we should be here. Yeah, so if we skip to process entry loop, first number should be 1916 something. And it is. That's weird. Okay. Guess let's do a few more iterations. 3, 4, 8. Yep. Let's do, what's that, 16 iterations? Can we do like cont 16? I don't know if that did 16 continuations, probably not. What is that, like do cont +2? No, I don't know what that is. Anyway, we are at 2985. Where is that? It's here. Okay, so we are in Soldier Fertile. Yeah, I guess it's just the end of file at the end, probably. I don't really understand why though. This should be hitting the event detection at the end. Then that's, well, actually, or should it be? Wait, do I need to spinulate my file? No, I don't. So let's break on. Wait, what just jumped to end of? Did recharge just jump to end of file? Oh, that's a different OniOS. Right. It's recharged OniOS, not started OniOS. It's different. So I guess we'll break on loop. I don't really have a good. Actually, no, I do. I can just break and reset done. One process. Yeah, and reset done. Oops. Window. Break here, and then that's that should be here, and that should be here, and that should be here, and here, and here, and here, and here. Okay, wait. So we should be. Oh shit! I think I skipped too many. We should be at the end now. Where does that take us? Skip until input. Probably that one. Yeah, that's correct. So let's read the character. What does it read? 0. Right. So that calls an EOF. That jumps into an EOF. What? Wait, what? It jumps into an EOF? Oh, that's our maximum loop? Oh my god, I forgot the ink IX. Okay. Yeah, that works. Okay, cool. Spent like half an hour debugging just to notice that I forgot this one. I should have checked that it doesn't actually hit on your edge. Kind of assumed it didn't, because it was like so simple. Okay, never mind. Then let's see if that is the correct answer. And it's not. It's too high. Okay, so let's actually check our ranges then. Is that inclusive? Wait, where did it explain that? There's range numbers, so again 1598.2. This contains two values, 98 and 99. Oh, it's exclusive. Okay, that's exclusive. That's probably why. So that means when we process, which one? When we process an input loop. Yeah, we actually don't want to do jump greater than, but jump greater than or equal. That's exclusive. And that's inclusive. So that's the same result, shit. So that didn't make a difference. Okay, that's 9. I guess let's try and get a more manageable input. So what if we do like these inputs? Actually, let's just use the input from that they have here. Just use that. Let's see what that one returns. It loops. Oh, that's fun. Oh, okay. So that backslash n at the end is actually necessary. I guess we can. Actually, I think we can simplify this a bit even. If we just use this one to check for end of file because it's more natural. Yeah, so if that's the one, then we can find the file. I guess we don't actually need the EOF check here then. Yeah, okay. I guess we can do it's not that, we can back. We can still keep the label because it's kind of useful for debugging. Actually, it's not because we have this one in here. Yeah, actually, it's not that useful. Okay. That obviously didn't work. Right, because now we need. No, this doesn't work anymore. Yeah, okay. But that's 86. Was that the correct answer? 50. Oh no, it was. Oh, I'm such an idiot. I'm supposed to find the minimum, not the maximum. Ah, god damn it. I'm tired today. Can you tell? So that's a theme of L, then not a theme of G. And that's why I used the first one with 0. Okay, so that's find min loop done, and that's min loop. And that's 0. Oh shit, that shouldn't be 0. Why is that 0? Where is that 0? Okay, let's get that one. Because our first input is 0, but it really shouldn't be. Why are you 0? Let's look at our input. 79, that fits into this range. Wait, no, that's not the range. That's the range. That fits into... Wait, what's the input format? It's destination source length. Right, so it fits into 50... Yeah, it fits into this range. And should be incremented by 2, not set to 0. Why is it set to 0? Process entry loop. So that's 12 is what? 50? Yeah, okay, that one shouldn't do anything. So now the range is what's that from negative 40? Negative 48? No, that seems wrong. Wait, why is wait, R13 is 98, that's the start of our range. And R14 is 100, that's the end, yeah, that's correct. And then this one should be yeah, negative 48, no actually, wait, I was in the wrong line. Yeah, that one, that's negative 48. This one should be plus 2. Yeah, so that seems correct. So we just check each one. I guess we put that one doing checking if it's has been set already. Yeah. No, it's greater than or equal. It's checking for the range. So it's not greater than or equal to 50? To 98, yeah. 98 plus 2. Wait, let me just look at the code. It's wait, where is the jump pressure equal coming from? Oh, I'm here already. Oh, I'm not. What? Where am I? What's this input loop? Fair, keyword, pointer, RBX, keyword pointer here. Oh, right. Yeah, I'm just checking the index. That's, yeah, that's fine. Right, so here, that's where we are. We're checking for if it has been modified already, which it hasn't. Skip that, and now we check for the start of our range. And it's not below that. That one shouldn't do it just wait, is it? Oh, it is, never mind. It is. Okay, so we skip that one. Yeah. Yeah, so we skip this one. Increment RBX and jump back in there. Don't jump out, yes. So we check if it has been modified already, which it hasn't. And now RBX plus 8 should be... Wait, what's R13? R13 is... wait, I'm checking the next number, right. So 14. Okay, let's do it that way then. Okay, so 14 should still jump out immediately, yes. And so should 55 and 13 actually. So, yep, that one works. And I'm not sure what happened there. Oh no, that was the last one. Yeah, okay. So I guess we can continue to the next entry, which should be 52, 50, 48. Yeah. So that's 52, 50, 48. It's here. Yeah, okay, so we massage that one into the right order. And check each one. And so the first one is 79, which should be in this range. Right, 50 plus 48, yeah, it should be in that range. So it should be between 50 and 98, and it is. Wait, why is input 0? Why is that one 0 already? Something went wrong there. Okay, let's rerun. Somehow input 0 got reset. Why? Why would input 0 have been reset? Why am I moving into inputs? moving out of inputs there, comparing, and C moving into RVX, yeah, out of inputs, moving into inputs initially. What? Okay, okay, I'm very confused. I guess let's just sit through here until it changes. Oh, that's the one. Two instructions above this one. Shit, that's a jump. Okay, okay, that's kind of problematic. Oh, missed it again. So it's an input loop. Done. Okay. Okay, so it's somewhere here. Something here is messing that up, and I don't know what. But how? It's not doing anything interesting. That's okay. We're fine. We're still fine. Still fine. Still fine. What's that doing? Look ahead, SHA. What? Look ahead, SHA is. Oh god, Jesus Christ. I know what's happening. This should only move a single character, but it's bleeding over into the next thing afterwards. Because we're moving an entire register at once. We're moving 8 bytes. So we are overriding the next 7. Jesus Christ, okay. So that's the issue. This should be a byte move. If we do that, that's 43. That's still wrong. But less wrong. Let's back on Earth and see if there are zeros, I guess. Wait, that's too high now. That's 83, 43, 86, 13, 0. Okay, actually that 0 could be correct, I don't know. Do we have results? We do, right? Let me just change my screen. We do, right? Yeah, we have seed number 79 corresponds to soil number 81. That's 82 for us. 14 corresponds to 14. That's 43. Okay. 55 to 57. That's 13. And 13 to 13. Oh no, wait, that's not location. That's just soil. Location 82. Yeah, that's correct. 43, 86, 35. Okay, so it's only seed 13 that's wrong. This one. That's 13 for us, somehow. And we have oh right, the 0 is just because the input is smaller than what we're printing. Because GDB. Yeah, okay, so let's check the soil numbers, I guess. Let's break on what's that one on loop? Yeah, that's 79, 14, 55, 13. Only one iteration, and it's still that. That's not what my breakpoint is on. What? Why are you not engineering? What? I'm confused. Okay. What? Why is it not just jumping, just breaking on loop like it should? What? Why are you? Oh, because there's no like instruction there. Can I put a note there? That help? Oh. Oh, wait, I didn't break anything. Yeah, that works. Okay. No idea if I need to do that. Okay, so it's only 81 is the only one that has. No, wait. It's 81, 14, wait, 14 stayed unchanged, yes. Then 57, yes, and then 13. Okay, so that's correct. The first iteration is correct. Let's check the next one. That's once more. That's fertilizer 81, fertilizer 53, fertilizer 57, fertilizer 52. That's wrong. Okay, so 13 did not get mapped to 52 correctly. Why did that not happen? So I guess it's in this map somewhere, whichever one should have mapped 13 did not do that correctly. Why? Why would it not? 13 fits into this range. And it's plus 39. Okay, so let's break on loop again. Yeah, okay, so that's the iteration we're looking for. And so we should break on process input loop. Actually, process entry loop. So that's the first one. Second one, third one. Okay. And now we should single step through it, I guess. Yeah. Okay, so now those are 39, wait, 39015, yeah. So our actual ranges are what? 39015, and then what? Wait, why didn't that do anything? So that's 39, that's correct. Oh, I guess those just match up somehow. So 39 is our offset, that's, yeah, because it's 0. And our end location is just 15. Okay, so just, yeah, didn't actually do anything. OS is Linux, Arch Linux, actually. If you ask like that. Well, technically Endeavor, if you want to be very precise. Yeah, okay, so we are here. And now what? Which iteration do we want to go to? The last one, so let's break on start or process, what's it called? Process input loop? Yeah. There. So we are here at 79, 14, 55, 13. Okay, so we are at 13. We are at the interesting one. Hello, Meta. Hope you had a nice stream. Hey, thanks for the wait. Wait, actually. How many E's do you have in the name? 4. Oh, Jesus. 13 incorrectly. Awesome. Hi. You were doing, weren't you doing Advent of Code? You were doing Clojure, right? No. Hello. Yeah, we're doing day 5. Because I've got into it. And it's actually really nice. It's, yeah, day 5 isn't that bad. Oh, nice, in Clojure. That's good. Yeah, it was probably a lot easier than the other ones then for you. Yeah, but yeah, day 5 was actually pretty straightforward because you can, like, there's a cool trick you can do. Actually, I don't want to spoil you too much, I guess. But like, you have these maps you're supposed to map through, right? But you can kind of do it in not quite reverse, but in kind of a strange order if you like, while reading the maps, kind of already apply them to your inputs. Yeah. Okay, cool. Yeah, but it's like, it's not that, well, it's only part 1 to be fair, but it's not that tricky. Right? You only have, you have these tables for like mapping seeds to salt and soil to fertilizer and so on. And like the way you're kind of intended to do them is that you like pass those into a map and then apply your maps like after one another to your inputs. You can just kind of read your inputs and then immediately apply them every time, and that's what I'm doing, because that means you don't need like dynamic memory allocation or anything. You can you only need your seeds array and like another array to, so you're not like applying the same map twice. But yeah, that's how that works. And I've technically been done for like an hour, but there's some stupid mistakes somewhere, and so somehow like this 13 isn't being mapped correctly, and I don't know why. Yeah, that's what I've been doing for the last hour and a half. Jesus. Yeah, but now I've finally tracked down the location. Right, there's in this line by processing 13, something is going wrong somehow, and I don't know what is. So I guess where am I? What? Oh Jesus! I missed it. Is my input count incorrect? Is that? Wait, what's input count? Yeah. That's 3, and I have 4 inputs. Ha! That's why. That explains a lot. Why is that? Wait, why is that wrong? Oh, because I'm jumping out before incrementing, right? Yeah. Since you increment R13 here, and then that's probably gonna work. Yeah, no, it's at 35. Okay, perfect. So, I guess we can try the full input now. Hopefully. And if we're lucky, that might be the correct answer. Let's try that. And that's the correct answer. Woo! Awesome. Okay, cool. Let's see what part 2 is about. Nice. Oh, that took way too long, honestly. Okay, but let me just get something to drink, because staying hydrated is important, folks. Okay, part 2. Everyone will starve if you only plant such a small number of seeds. Reading the almanac, it looks like the seeds line actually describes the ranges of seed numbers. The values on the initial seeds line come in pairs. Within each pair, the first value is the start of the range and the second value is the length of the range. Oh wow. So in the first line, the example above, this line describes 2 ranges of seed numbers to be planted in the garden, 79 to 14 and 55 to 13. Oh, 55 with length 13. Right. Things always take me forever, especially for AC. Yeah. Yeah, it took, yeah. Well, this took me like an hour more than it should have, to be honest. So, I know what you mean. Yeah, but honestly, that's kind of part of why I'm doing Advent of Code in assembly, because like, if you are doing it in assembly, no one expects you to be like fast. Like if you take 2 hours, that's kind of expected. And like, you can just have fun doing like writing assembly or whatever. Yeah, okay. Now rather than considering 4 seed numbers, you need to consider a total of 27 seed numbers. Wait, but how? Oh god. Actually, does that make anything harder? Alright, see you later. Bye. Actually, does that make that harder even? Because, wait, I guess if you can like sort them on every iteration. Wait, so like, okay, so let's say we have, like, let's say our inputs are 1, 2, 3, 4, right? I guess, oh yeah, I think you can just massage the inputs a bit and then like reuse the same logic. So if you, like instead of start length, you kind of transform that back into start end indices, right? And then it's 27 in this case. And then you apply like the mapping to each one. So in the next line you get maybe, I don't know, 6, 2, and let's say, I know, 5, 9, why not? Then you kind of, yeah, I guess you can just, yeah, I guess you could just like, actually does that work? Does that work? no, it doesn't work because ranges might be applied differently, right? Like the first half of the range might be mapped differently than the second half. And that's tricky. Yeah. Okay, so kind of feel bad because I just got raided, but I think I'm not gonna be able to do that today because it's already kind of late for me. Yeah, wait, let me just think about it if there's like an easy solution. But like my idea was that you could just like map the ends of the range, and then if that works, like only actually process the range correctly at the end. But I don't think that works. No, that doesn't work. Cause like I guess you'd need to split up the range like according to your input. Right, if you have like 1, 3 and you have like, or actually let's say you have like 1, 5 and your input maps like 1 to 2 to, I don't know, plus 8, plus 10, let's say, and maybe 3 to 5 to plus 20, then you need to map that one forward to like 11 to 12 and also 23 to 25. I think that's gonna work, but that's really annoying to implement. Actually, I think that works if you like do this in pairs of ranges and then like split every range up according to your input. I think that works, but that's also gonna be a lot of ranges. But I don't think that's that bad. Yeah, I think you can do that. Oh boy. I think you can do that. Yeah, if you just split up the range according to this, and then just do that as a like pre-processing step, then I don't think you need to do anything else. And I think you can just keep the logic. Because now those are like after you've done this, every range should use the same mapping, so you can just map the endpoints. And the ones in between should be mapped like linearly. Right? Yeah, so you just need to map the endpoints, 11, 12, and 23, 25. And then you do the same thing again. And I guess you could sort of merge ranges if possible, but you don't have to. Ah, yeah, I think that works. I kind of want to try that, but I don't think I have the time. You know what, that's... Wait, how... no, I'm not gonna do it today. I'm gonna do that some other time. So, yeah, sorry for all the raiders that just came in, but guess I'm gonna find someone else to right now. Was a fun stream though, and yeah, guess I'm gonna. If I find the time, I'm gonna stream tomorrow probably, and then we'll do day 2, part 2, no day 2. Then we'll do part 2, and we'll try this like splitting up ranges thing, because I'm pretty sure this is gonna work. And then you just... Actually, you only even care about the lower endpoint every time. Actually, wait. Before I do that. We only ever care about the lower endpoint, right? And mappings only, like, add an offset, right? So we only ever care about... Do we only ever care about the lower offset? Is that how it works? So we can just ignore the second number, and then that's gonna work. Wait, okay, I need to try that. Okay, wait, because, okay, like, let me just think for that. So let's say we have a range, like 1, 5, right? From index 1 to 5 inclusive. That would be represented as 1, 4, but we can process that into 1, 5, right? And we apply some function to it, like, right, like we apply some... oh no, we don't. Never mind. Because we might map 1 to 2 to... we only ever care about the lower... No, we only care about the lower endpoints at the end, but we do still need the upper endpoints so we can like apply the correct mappings. So if like 1 to 2 applies plus 100 and like 3 to 5 applies plus 10, then we care about the 3, right? Then 13 is gonna be the lowest one. Okay, so we do need to split up ranges like this, but we only need to collect the lower endpoints at the end then. Okay, so that's what we're gonna do tomorrow, and I'm gonna find someone to raid. Thanks for watching. Yeah. Oh, Antoine is streaming. Okay, so I guess we can get all of you to read some Haskell then. Yeah, so I'm gonna read one, and see you next time. Bye everyone.